morning all. This is the second webinar of the series of webinar sessions brought to you by ICFOSS. Our last webinar was on Big Data Analytics. Today, we welcome you to the second webinar on Mathematical Foundation for Machine Learning. Let's familiarize ICFOSS a little. Many of us are familiar with ICFOSS and its whole family. The International Center for Free and Open Source Software aims to leverage the idea of force and thereby enhancing the quality of lifestyle of the young generations of Kerala. ICFOSS is always in lead introducing new technologies which are really of lead for all of the different parts of the community of Kerala. ICFOSS came to the forefront of technical training sessions, winter and summer schools on emerging technologies, back-to-work programs for women, residential camps for young ladies who are in the tech field, and whatnot. We do not roll out the trainings and ignore the participants behind. Instead, they are all brought together under one umbrella to introduce and enlighten them with new ideas and innovations that happen in the tech world. Our relationship with the participants is a never-ending one. We do have a sincere intention of guiding you and helping you achieve new heights in your career. Before we start our session, I have a kind reminder for all the participants. Kindly mute your mic during the presentation of the session. It may interfere with the voice of the presenter and this may cause interruptions for the session. So you can always put your doubts in the public chat session. After the session, the relevant doubts will be asked and the doubts can be cleared. So kindly mute your mic during the session is going on. And also we have a Telegram group set up for you for your future doubts and if you have any help needed. The Telegram group link will be shared to you in between. So we are entering into the main agenda of the program. I extend my hearty welcome to the ICFOSS Director, Dr. Shabirish Karunakaran. Dr. Shabirish Karunakaran was the former e-governance head of Kerala State IT Mission, and he is a leading personality in implementing various e-governance projects and several web-based applications. So we are grateful to have you for this webinar series. I welcome Shabirish sir to talk to you and deliver the introductory note. Sir, the session is all yours now. Yes, sir, you're audible now.
Okay. Thank you, Rina, for a nice intro. And on behalf of ICFOSS, I welcome all the participants to the second edition of our webinar series. And this time, I think we have a interesting topic and an underexplored aspect of NLP or artificial intelligence, that is the basis of AI and NLP. I think today we have a great speaker with us, Dr. who will enlighten us with the all of the students who are assembled here. Make you talk and take it forward. And if you have any further more doubts, or if you want to connect with, you're welcome. it is there. I mean, ICFOSS is with you. With that small. Hello. I welcome all to this event. Thank you.
We're now on mute.
Thank you, sir. As we all know, our today's session is handled by Dr. Umesh P. on mathematical foundations for machine learning. Dr. Umesh has completed his master's degree in mathematics from Cornell University and MA from University of Kerala. He got a PhD in the year 2014 in bioinformatics and computational biology from University of Kerala. He started off his career as bioinformatics consultant and then he joined the Department of Computational Biology and Bioinformatics at University of Kerala as a senior research fellow. In 2015, he joined College of Engineering Aranmula as an assistant professor. He is currently working as an assistant professor at College of Engineering, Palashiri. So it is my great privilege to invite Dr. Umesh P. to handle the session. Sir, I hand over the session to you.
Good morning all. I hope I am audible and I welcome all of you to the second program. A very relevant nowadays. People are discussing machine learning in no-code product. So it is very relevant topic to discuss on what more mathematical foundation can do. Okay, is there an echo?
We're now on mute.
No sir, I think everything is fine.
Okay. So for a disclaimer, I can say that since it is a webinar session, a voice break may come. Please make sure that all of you mute your audio, and I also after some time I will switch off my webcam so that it is better for good communication. Bandwidth speed. So I once again welcome all of you to the session. Okay. So what we are discussing is mathematical foundation for machine learning. Okay. So to start, I can assure you that I will only tell about the basic aspect of mathematical part, not very focused on very deep on mathematical part. So second is for the time and the duration is 1 hour, so I will discuss only the basics of how it is being used in machine learning, so that you can learn it or you can go through some textbook or web resources later, so that you will get an idea how to focus on how to deal with this topic. Okay, so while speaking machine learning, most of you have these emblems in your mind, these logos in your mind: Python, TensorFlow, NumPy, Keras, etc. If you are from industry, you will be having a much more broader picture, like you will be having much more things like Hadoop, etc. and about cloud and local and cluster and testing, deploying, etc. So I am not focusing on all these aspects. I will be focusing on only the aspect where mathematical overlap is there with machine learning. So it's a famous mathematician and computer scientist, Richard Feynman. His famous saying is that what I cannot create, I do not understand. I take some excuse from his words that it is always not happen with the machine learning, but people create projects or people create machine learning algorithms or topics without understanding it in a deeper sense. So in some sense, this line is not true when we are speaking about machine learning enthusiasts. I am basically a teacher. I teach in engineering college. So in engineering college, you can find many students who are interested and focused on machine learning or artificial intelligence, but they only know how to code it, but not to understand in a sense of like what people have to do. So to put in perspective, I can give an example that people create machine learning projects. For example, this is a simple code to create a neural network by using machine learning algorithms and machine learning packages. So Keras is one of the packages which is used for creating machine learning algorithms, machine learning projects. So in this, you can simply create a machine learning project by using step-up lines. Okay, you just need to plug into what you have to do in the particular lines. Okay, so in that sense it's simple, but after doing this, you arrive at a black box where you will find answers like this. Okay, so you will be getting some answer or you will be getting some result like this. But where a challenge comes in is you need to interpret this result. Okay, you need to interpret this result. Okay. Okay. So in that sense, we have to do some kind of mathematical understanding how this algorithm works and what are these factors inside this algorithm, and only you will understand in a better way. So in this 1 hour session, I will try to bring you or bring into focus of this black box, machine learning black box, so that you will go deep into this black box and understand or open this black box, or you can make a transparent box instead of this black box. So machine learning is almost math and learning. Okay, so we put math more on machine learning because we need how to search or how to select a right algorithm for your particular project. Okay, then how to choose parameter settings and validation strategies. Sometimes you will be come across with some underfitting or overfitting issues. So how you do with these trade-offs? And then next is how to deal with uncertainty. These are the main focus points where you need to concentrate or do more on math than or coding machine learning projects in this sense. Okay, so how much? Then the problem is how much math I need to know, or how much math is needed to understand this machine learning. So at least for some people it is very disappointing that mathematics is required for a quantity of mathematics is required for machine learning. But I can say that machine learning projects or machine learning algorithms, most of the algorithms are written in mathematics, and to understand that in better way, you have to go in deep in mathematical language where it was written. For example, when you see the workflow or the pipeline of machine learning project, it is to enter your data and represent data and prepare model, search and visualize the data. All this comes with a mathematical tagging. So whenever you go to a new textbook, you have to understand this concept, and you can understand only if you understand this notation. Otherwise, what happens, you will be understanding only the basic workflow, and you are doing like blah blah blah, and without understanding much of the aspect in machine learning, you will be come across with, or you will be end up with a result. And what happens is after that you cannot go further forward because without understanding the algorithm, you cannot interpret the result. So that is a basic aspect what we have to focus on. Okay. So while speaking about machine learning and data science, there are subtle difference. You can see, you can access with some of the good materials or good reading materials on machine learning and data science. You will come across with this kind of graph where data science more often used using statistics and probability than of multivariate calculus and linear algebra. which is being used in machine learning. So more of statistics and probability is required data science, but for machine learning you can have less of that knowledge in probability and statistics, but you need to have focus more on multivariate calculus linear algebra. Okay, so again, mathematics has different kind of branch. It is a huge and vast topic. While I am saying that it is required for machine learning, to understand machine learning, it is mathematics is required. So you'll be having a feeling that, oh, everything has gone from my hand. So that is not true, but mathematics is a big tree. You can assume that it is a big tree having different branches. But to understand a kind of machine learning algorithms, understand machine learning in a better way, you have to focus only for some branches like calculus, probability, statistics, and linear algebra. And if you can focus on these some branches, you can obviously go forward with the machine learning algorithms, and you can understand machine learning algorithm in better than that of doing machine learning projects. Okay, so I'll now dive into linear algebra. And linear algebra, I'll start from the school linear algebra to graduate linear algebra. That is all required for understanding machine learning projects, because you may not focus on more theoretical aspects, but you have to focus on theory as well as the overlap between theory and the practical application of linear algebra in machine learning. Okay, so while speaking about linear algebra, you might have good understanding about your linear equations, and linear equations are most important thing. And linear equation always, linear equation is looking like y equal to mx plus c. If you plot the equation, you will be getting a graph like this. Okay, so if you have more variable, you can get a plane than that of equation of a plane. So this plot for equation that is equal to 2x plus 5y plus 2. Okay, so to find solution, so solution of linear equation means graphically we can we need to identify the point of intersection between two lines, and analytically we can solve these particular two equations and to find values for x and y. So analytically it is solving the for x and y. Graphically it is like finding the point of meet or point of intersection of these two equations or these two lines. Okay. So when you have these particular things, there are particular cases like you can have a unique solution, and sometimes you cannot find any solution, but sometimes you can find infinitely many solutions because these two lines overlap. So there are three cases of linear solution of linear equation, and when you speak about space that is more than 2 dimensions, you can arrive at a plane. So again here you can focus on the intersection of planes. So if the planes are intersecting, you can get a unique solution. Otherwise, the solution is different. So you can have a look on all these aspects of linear algebra, how to arrive at a solution, and what are the different needs for different type of getting a solution from a linear equation. Okay, to solve the linear equation, classically we use matrices. Okay, you convert a linear equation, system of linear equations into a matrix. So after that, it's very easy to solve that because matrix manipulation is very easy in computer. So actually, usually in older days people use MATLAB for manipulating matrices, but nowadays MATLAB is not very common. You can use Python, NumPy, free open source softwares and tools, or you can focus on R programming. So you can suddenly go to kind of matrix manipulation and get the answer. So typically we can say there are different cases of vectors while you are dealing with computer programming and linear algebra. You can arrive at three different types. One is vector, second is matrix, and then there's a tensor. Okay. So in that sense, vector is it can be a column or row vector. It's a one kind of array, dimensional kind of array. And if you can have n by n or m by n kind of values, you can come across matrices. Then if you plug that kind of matrices together, you'll be getting tensor. Okay. So notation, regarding the notation, usually in the textbook and reference, you will be seeing either x cap or bold letters as vector, and you do not the attributes of vector with an x-ray with a superscript. And for multiplication, is the sigma, and multiplication we use pi. So these are the notations we are using for that. So to solve matrices or to solve system of equation, we have different lower term form, and we can always do this kind of problems by using reducing that into lower dimensions, or reducing that matrices into lower term form or block form, and we can solve the report x by s. That is the purpose of solving this equation. So actually we are solving the equation we are getting x by x. Okay. These are the Primus matrices, and always in machine learning, matrices is being with transformation means it can be an enlargement or rotation or scaling. Okay. So see the transformation matrix 0.53 or minus 0.85, 0.82, 0.53. So I use this transformation matrix over this red box, and that it is transformed, and you can see it in the right plane. Again, if you apply the transformation matrix on this particular points, you can get the points transformed and you get a new picture. So this is a kind of transformation we apply on geometry. Actually, I apply transformation on each point of this rectangle and this square, but you can have a different kind of notion for this transformation. What is the take-home point is, so if you have a matrix and you can apply this matrix over some vector or again a matrix, what happens is the given vector or matrix is transformed, or it is at least rotated or modified or scaled or enlarged in some kind of way based on the transformation matrix. Actually, transformation matrix determine what kind of transformation can be or what kind of transformation is done on the particular points. Okay. Here, another example of transformation matrix is a scaling matrix. So 2 0 0 is a scaling matrix. When I apply transformation, what happens? The red square, which is the actual points of pixels, and that gets transformed. In this case, it is enlarged to some other level. So similar way, you can see in the right plane also the figure is getting enlarged. So this transformation matrix is matrix of enlarged. Okay. In some other case, if you use transformation matrix like this, the transformation happens in some order and it gives some other figure for the transformation. Okay, these are about transformation. And one more important point in the linear algebra is the basis. Okay, so if you have linear combination of vectors, okay, if you have linear combination of vectors, and if you can write a vector into linear combination of some other vectors, and these vectors are linearly independent, you can say that types of bases. Okay, so you can also examples for bases. Okay, for some base also. Okay, if that is said to be a orthogonal basis if the dot product is 0, dot product of vector is 0, and orthonormal if it is orthogonal plus normal. So we have to think about orthonormal basis. That means orthogonal plus normal. Okay, so the basis is that set of factors in the linear combination where the linear combination is always linearly independent. Again, we can refer the eigenvalue and eigenvalue problem. Eigenvalue is identified or found by determining that a minus lambda I equal to 0. Usually it is called spec in some programming language. So eigenvalue is the characteristic value of the matrix, like what the determinant says. It also encapsulates some behavior of the matrix. So the eigenvalue is eigenvalue. You can also find eigenvector. Okay, eigenvector. Eigenvector for each eigenvalue can be found. Okay. So this is very important. So for n vectors, u1, u2, etc. un, the linear combination vector is like what you can see in the screen: alpha 1 u1 plus alpha u2 plus etc. plus alpha un. So this is called linear combination of vectors. So linear combination is nothing but you fix some variables or some constant, and then after you put some vector. So when you add in that way, you will get linear combination of vectors. Next is norm. Norm is usually used for denoting length. So norm is measure of length of a vector. So there are different kinds of norms, like Euclidean norm and infinity norm, etc. So we will discuss this norm in future coming session. I just wanted to brush up over this concept in your mind so that you can connect that into machine learning. So we have linear independent set. Okay, so linear combination and linear independence we can see in this particular example. Okay, so if we can represent one vector in terms of other vector, you can say that that vector is linearly independent, otherwise it is linearly independent. For example, see the bottom x1, x2, x3. So here x3 can be represented by using x2, so that these two are now linearly independent. Okay, so basis is a set of linearly independent vectors, and the minimal set of spanning vectors that is called basis. Usually you refer basis as the unit vectors around each dimension. So that makes the basis for 3 dimensions. Now usually hear PCA, principal component analysis. Actually this comes from covariance space, and if you find covariance matrix and then you take eigenvectors of this covariance, that makes the PCA basis vectors. So PCA, principal component analysis, is directly a topic that is very related to this eigenvectors. So we have to know covariance, we have to compute the covariance of data, then we need to take the eigenvectors of the covariance, then it will suddenly give you the PCA basis vectors, principal component basis vectors. So some frequently used distance measures are mean square, Chebyshev, Euclidean, etc., Manhattan, etc. So the distance measures are different because that makes different sense. So Euclidean is shorter distance, you can see the figure, and the distance is measured in different sense, so that it happens on your different program. So in case of that different, like if you are see you are using distance, shortest distance between 2 points, you use Euclidean distance. So if it is related to angle, so you use cosine similarity. And if you are using some string or vectors with strings, or alphabets, you can use Hamming distance. So according to the purpose, you can use the distance measures. There are several cases of distance measure. So based on your application, based on your use, you can use this distance measure. So next is orthogonal projection. So the projection is again a transformation where you can apply this matrix P on this particular vector. That means the projection of this particular vector X on some plane. So projection is also very important machine learning project. Usually you see the projection of points on a line in machine learning aspect. Usually you see that in the regression kind of analysis, you actually find the projection of this point on the line so that you can measure the distance between the regression lines that you receive and these points. Next, let us go to brush up some calculus. Okay, so calculus, when you discuss your calculus, graduation calculus, first of all, it is a function. Function takes values, input values, and it computes some function. You can say as a black box, or you can input some values for x, and it readily gives output like x square values of output. Okay, so you can plot the function or graph, and you can see that in some sense you can see there are some points where you can see minimum or maximum. And minimum, you can see there are two kinds of minimum. One is local minimum, that is you can see in locality you can see a minimum point, and global minimum, it is a minimum for the whole function. So it is very important to understand local minimum and global minimum, and for finding this minimum we use the concept of calculus, the concept of differentiation. Okay, so in that sense we use slope. Slope is like you can see that in a particular line or particular graph, if the slope is 0, that means it is some point where the graph is not changing, or the rate of change of this graph is 0. Okay, that can be either a maximum or minimum point. So in case of positive slope, that means the function is increasing. In case of negative slope, that means it is decreasing. And in case of slope equal to 0, you can say that the slope equal to 0 means the function has arrived at minimum. So derivative and slope are similar concept. Okay, derivative and slope are similar concept. See this graph. This is a particular graph of function. You can see the blue line is a function. When you plot the derivative graph, you will be getting the green dotted line. Okay, the green dotted line is a derivative graph line. Okay, that not line, it's a curve. Okay, so according to this, you can say that when the difference, okay, when the slope is 0, what happens? Here the slope is 0. The derivative graph meet with the point, x point. This is 0 point, right? Okay, see here the slope is 0, then it meet with the point. Here also the slope is 0, and then meet the point with the axis. So this is how you should understand the derivative slope are the same kind of concept that we can use in the aspect of machine learning. So if you are interested to find the improvement or maxima or minima, we can discuss on focus on the derivative concept. Okay. Here you can see some of examples on derivative the graph. Here also a function g of w is given, and in the bottom you can see the derivative term. Okay, so whenever you see the slope equal to 0, the derivative graph meet with the x-axis. So whenever you see the third you can see many points where the function has slope 0. In that all points, you can see that the graph meets the axis. So you can use the points or the maximum minimum points and derivative concept in either way. Okay. Now, when you talk about this derivative, I have discussed the derivative and slope, or the minimum points and maximum points can be identified by taking the derivative or equating the derivative to 0. But for some case, you will be come across with some functions with more than one variable. Okay, in that case, you usually say multivariate calculus. In this multivariate analysis, you need to use partial derivative. Okay, you have different planes. One is x, but other is y. So in this figure, you can travel via x direction. Okay, see the green line. Also, you can travel via y direction. See the red line. So you have to find slope when you travel in the x direction is a partial derivative with respect to x. You can travel via y direction and find the slope. That is the derivative with respect to y. So partial derivatives are the concept where we are using to find the derivative or steepness or the maxima or minima of the curve based on the axis. Okay, based on the variable. So here we can focus on this plotted function of two variables x and y. Okay, function of two variables x and y. If you are interested to find the change in x, you can take the partial derivative with respect to x. If you are interested to know the change in y, you can find the partial derivative with respect to y. Okay. Next is gradient. Gradient is a particular operator where you use to find the derivative concept itself. So in that you use the partial derivative as components. In some reference, you can see derivative as a column vector or a row vector. In that, elements are the components are partial derivatives of the variables. Okay. Here I represent as a form of vector. In some reading material, you can see this gradient as partial derivative. That can be a column or a row partial derivative component. So you might, if you have, I discussed any machine learning, or if you have gone through any machine learning textbooks, you can see that term called gradient descent. Okay, gradient is actually I discussed the gradient because gradient is somewhat a concept related to identifying or finding the steepness or change of the function. Okay, if the gradient is 0, that means the function has either maximum or minimum. So gradient descent means the algorithm always tries to find the place or try to find the location where gradient is low, small. Okay, gradient is small. So gradient descent approach is approach where you can focus or you can travel through the function and try to find the minimum gradient, or at least at last you end up with gradient equal to 0. So you always try to find a lesser gradient. So the word meaning indicates that gradient descent. So we always try to find the lesser gradient while traveling the graph. So gradient descent approach is used for finding the optimal values for the function in machine learning, most often in neural networks. So now let us discuss probability and statistics. So I will discuss each topic in a bird's eye view, so that I brush up this topic and I go to the machine learning approach and I discuss where it is being used. And that is the purpose of today's session. So since it is only 1 hour, we can discuss all the concept of mathematics in broader way, but I will discuss the term and then I dive into the machine learning algorithms and I'll discuss where it is being used, and that will be useful for you to learn or read the machine learning reference and identify or understand what it is speaking about. Okay. There are different statistical methods. One is descriptive method and inference methods. And in descriptive method, there are univariate, bivariate, and multivariate. The variate suddenly gives an idea about what are the variables, how many variables inside that. Okay. If it is only one variable, it is univariate. Discussing it two, bivariate, then multivariate. Then inference statistics is about finding hypothesis testing inference from a data. So both is being used for machine learning projects, but most often the descriptive stat methods are used for machine learning algorithms. Inference statistics also used for finding the accuracy trade-off of machine learning research projects. So in descriptive methods, correlation, regression are the and multiple regression are the important points. So we will go to see what it is. So you have population and sample. In the statistics, population is all data together, and if you take samples, the way you take its sample is selected item from population. Okay, univariate, you can see this graph, right? So univariate means it is only the variable is only one direction, or only one variable is if you are measuring the hydrophobic level of one or hemoglobin level of person. So that is the univariate data. Okay. So bivariate means you are discussing about two variations, triglyceride versus LDL. And if you are measuring variation of three measures, you can go to the trivariate or multivariate. So mean is a simple summary statistics that is being used in machine learning. Okay. So mean and standard deviation can be used for making or exploring the data in the first sense, first look. Okay. So mean is about central tendency and standard deviation is about spread. Okay. If you have larger spread, okay, if you have standard deviation equal to 30, you have larger spread in data. If you are having standard deviation equal to 10, you have less spread. Okay. According to this, you can see the first figure is having low spread because it is having low standard deviation. Okay. Higher spread means higher standard deviation. Actually, mean is the balance point, and you have to be very careful about speaking about mean because it is a problem that it can be affected or pose its outliers. For example, if you add income of all people inside India, Ambani and the person having very rich is an outlier. So if you take mean, that means our annual income becomes maybe 50 lakhs or so. So that is not true. Okay, so we have to be very careful about outliers when we are dealing about mean. Also, median is another important tendency of central tendency, and it is measured a variable. It is ranked between points, and then it is measured the 50th percentile is usually called mean, and there are different percentages based on you can analyze the data. Okay, so median is the data where you can see the central point. It's again a measure of central tendency. Okay. Also, the problem of median is it is also affected with the outliers, less affected with outliers, and you can solve the problem of mean with this kind of median. Also, the typical person, Ambani, is again an outlier, and the data gets skewed while you are dealing with mean. Okay, mean is again, median is again a tendency of measure of data, central tendency, and for skewed data you have to be very careful about taking about mean and median, and for symmetric data actually this always connects together and this actually binds. Okay, so continue until you can go further forward. So we'll discuss about variance now. Okay, variance is again discussing about the spread of data. Okay, variance is more spread means you can see the figure. So more spread means you have more variance, and less spread means you have less variance. Next is covariance. Covariance of values can be identified with the two variables. So how it is covariated? The word indicates how it is variated, and you can see identify the if x and y are varying or vary in concept, or whether it is having synchronized behavior. You can identify by using covariance. If it is not synchronized, that means the covariance will be more. Okay. If y increases, then x increases. Factors can be measured by using covariance. And next is correlation coefficient, and this is always range value between -1 and 1. Okay, so here also correlation coefficients actually roughly indicates the degree to which this varies. This variation is accounted. Okay, this degree at which this variation is accounted. You can plot the correlation coefficient and identify the variable differences. Next, let's dive into probability. Probability and statistics is different because statistics is always discussing with what is happened, and the probability is always discussing what will happen in, or it is kind of modeling approach of the data. So statistics is dealing with what has already happened, and probability is always discussing it and what will happen with the prior knowledge is there. And you know about the experiment outcome, event and probability. These are the basics. Probability is the uncertainty in the data science. It will measure the change or measure the uncertainty. Mathematical uncertainty or mathematical measure of chance is done by using probability. It is always varying between 0 and 1. 0 means less probability and 1 means higher probability. Probability attacks the randomness, and you can use probability to match or deal with the incomplete data, or incomplete model can be fixed by using probabilistic approach. So in case of tossing of a die, these are the probabilities. If it is a fair die, you can see the probabilities are equal. The conditional probability is one of the important aspects of modeling. For this we use a bar, which is felt as probability of x1 given x2. That is, given the case of x2, what is the probability of x1? It is computed numerically, mathematically, by taking the intersection of x1 and x2 and divide with the probability of x2. Okay. So this is can be used in, you can multiply, or you can take this 3 of x2 in this side. You can get another formula for intersection of probabilities by using conditional probability. So we say conditional probability is very important because it is the starting point of set of Bayesian algorithm or Bayes theorem. Bayes theorem is a particular thing. This can be used for identifying next probabilities by using prior probability. I'll focus here with an example. If I am using different mode of transport like car, bus and train, and I am using equal priorities, that is the chance is 0.33, that is 1 out of 3, 0.33, and the probability of getting late if I am using car is 50%, and probability of late if I am using bus is 20%, and probability of getting late if I am using train is 1%. In that sense, you can, if I am late, see this point, if I am late, I can find whether I use mode of transport as car or bus or train. I tell again, the probability of I am late if I am using each of the transport is given. But next time if I am late, my boss can measure whether boss can find whether I have used mode of transport car, bus or train. This is a start of modeling or start of prediction. The boss can predict which transport I have used, which mode of transport I have used with prior knowledge. If you compute this in better way, that means I have probability of, if I am used mode of transport car, I have used mode of transport car, the probability of late is given 0.5. And probability of using car is also given. If these two factors are given, see here late given car, I can find car given late. Okay, I can find car given late if I am provided with the prior probability, prior information. This is the point where you can use Bayes algorithm, conditional probability to model the values. Okay. And probability mass function is very important. And expectation is a quantity where you multiply with the input variable with the probabilities, you get expectation. Expectation, you can correlate expectation, or you can put in perspective of expectation with the mean of probabilities. Okay, concept of mean with the probabilities. So you can also, again, for probabilities you can find variance, covariance, etc. Every time if you are dealing with probabilities, you will be using concept of expectation. And further forward, in data, you have further forward variance and covariance, etc. But only the differences you are using, instead of frequencies and data points, if you are using in statistics, instead of that you are using probabilities and expectation. Okay, probabilities and expectation in the case of you are using modeling probabilities. Okay, the notion and the formula are similar, the concept is also similar, but only the difference is, instead of mean you are using expectation, and the probabilities are using instead of the frequencies. Okay. So I quickly go to question. I'm calculating it. After the start of this thing, we can discuss how language of mathematics is used in machine learning. Actually, this is the important part of the presentation, important part of today's discussion. What I discussed is to getting acquaintance with the concept, or what are the concepts that you have to read before going or before learning the machine learning or algorithms. Okay, you can find many textbooks and reading material online, but all the problem is all that materials written, good algorithm materials are written in terms of mathematical notation. So I discussed the main concept in linear algebra, probability and calculus. All these concepts, if you read or if you have a sufficient background in all these topics, so you can quickly dive into machine learning and you can understand the language where the machine learning algorithms work. With some examples I will discuss this topic. Okay. So first of all, there are two different methods. One is supervised learning and second is unsupervised learning. Okay. Many of the topics we labeled some photographs of human, like male and female. You can identify the person, whether the person is male or female, with the passport size photograph. Suppose that this is our problem. In this problem, the label data means the features of eye, nose, and lip and ear of the person in the photograph, and that should be labeled with a male or female. Labels are male or female, and the features are actually nose, lips, eyes, etc. Actually, input data is the pixels of data or pixel of image, but by merely given the pixels, computers or algorithms cannot understand or identify the features. Either you have to say about some features, or you have to give these are the features, and the feature vector can be input to the system. Then only it will identify or understand in better sense. So in this case, if you are using passport size photograph to identify the gender, in that sense, the features like eye, nose, and other features are feature vectors, and labels are male or female. And supervised learning algorithm starts here. Okay, supervised learning algorithm is labeled examples xi, y, where element xi are the feature vectors and yi are the finite set of cases, like here what we discussed is finite set of cases like in the field. And supervised learning algorithm is try to produce a model that takes feature vector and compares with the output, and whether decides or it arrays a model where you can use some of the feature vectors data and array with a model where you can use the model to predict whether the given photograph is of male or female. And unsupervised look at the labels. Okay, so the equation hyperplane. You can see the concept of hyperplane mostly in the machine learning. Hyperplane is the real value vector W with the input variables, and E are the real number. Then if it is for one dimension, we can say that is a line. This means W1 x1, W2 x2. So let us look into linear regression, how the concept is used in linear regression. Again, there is a set of labeled samples can be used for linear regression. For linear regression, we try to find a line for dimension. We can one is number of person, that is this blood sugar level. This is a unit where the slopes are given and the intercept are given. Okay, so the linear regression ultimately discuss about finding equation of line or equation of plane. It can be identified. So in the figure, linear regression simply for two-dimensional data, that is univariate data. You need to find a line where it connects x with y. Values b0 and b1. Actually, the purpose is find b0 and b1. Actually, b1 is the slope and b0 is the y-intercept. So we need to find b0 and b1, and then only we can produce the line. If the line fits almost all the data points, that means your linear regression is successful. Okay. So for the linear regression, you need to find first of all linear algebra. And then host function, you can always see the host function of host function in linear regression, which is like the model data difference between the original data with the model data, and you find it 1 by n. So it works like a mean. Okay, so this is always closed in linear regression analysis. So it actually find the difference between the data points and the is created by the linear regression model. So if the loss function is more, that means our regression models are yet to improve. If it is small, that means we are very good at the regression analysis. Sometimes you have to focus on the overfitting and underfitting of data. The regression analysis, you always need to find it. Sometimes it will be right line. If you fit the data by using non-linear curves, and this makes up underfitting, overfitting of the data, this is always not good for the modeling. So you need to get the loss function or force function minimal and get the modeling to be worked on the data. So the linear regression is about to find the equation of line or plane wx plus b for b0 b1x plus b0 for univariate data. Now the logistic equation says if this particular input is put inside the e raised to minus half. So if you find again the function w f of w dx, this makes the logistic equation. Okay. This makes the logistic. Actually, the logistic equation is having a particular shape of this curve. This curve is S-type curve. The peculiarity of this 1 by e raised to minus x is this curve. Okay. The shape of this curve is determined by the function. If you plot 1 plus e raised to minus x, you will be getting a curve like this. And little line or plane that you receive, you put that inside this e raised to minus x, you will get that logistic equation. This is actually is like a fuzzy kind of thing. It ranges between 0 and probabilities between. You can find the chances of following this particular in case of identifying male or female. What is the chance of being that particular photograph male or particular photograph female? Can be using logistic regression. And the gradient descent algorithm also takes the partial derivative and seeks the minimal gradient, the slope or the derivative function, and try to find the minimal descent, minimal gradient, so that minimal gradient means we'll always try to find the minimum of the function. Okay, so we'll try to that. So we start with some point and try to find the minimum of the point, the minimum gradient of the point. When you arrive at a point where you can see that is possibly a minimum point. So we have to be careful about dealing with the unit case in this. Right. So gradient descent is always having different iterations. That is called FO. So FO consists of using training set entirely to update each and every parameter, and FO means how many different trials that you have done for make this gradient descent or make these gradients minimal, so that if you arrive at some point where you get minimum gradient, you can say that you can stop the procedure, or you will, after proceeding further forward, you are getting similar kind of values, or there is no difference or not much change in values, so you can stop at that point where you get similar values as output. So always related with the number of trials of the machine learning software. For example, if you try to do the linear regression or FO 3000, you almost arrive at a point where connects almost all the data. So in that sense, we can say that for more FO, it can more over connected to each points. So also name-based, we use the Bayesian algorithm, where you connect the likelihood and the prior probabilities as I discussed in the conditional probability case, where you can measure the probabilities of using a particular vehicle if I am late. So likelihood is used that the previous prior data. In that example, in that particular example, the prior data is the probability of getting late when you ask for it. So the prior data can be used for modeling the next data. So procedure probability is given the next level prediction, and likelihood is the prior data, and you can use this data to find the probabilities. So this directly comes to the base theorem, and the base theorem can be directly used for finding the naive-based classification, naive-based understanding. And normalization and standardization are the two processes where you use for the machine learning algorithm. Normalization is you convert the values into possibly 0 and 1 or minus 1 to 1 by taking like subtracting the minimum and dividing with the maximum and minimum points. And standardization, you get the set-score normalization, you get dividing, subtracting by mean value and dividing the standard deviation, you get the standardization. So if you select a learning algorithm, you have to explain the result, then the number of features in the examples are to be in line with the algorithm that is selected. For example, for the neural network are known for using large scale data. You can use large number of data for training or testing for case neural network. So that is the selection of algorithm. So you need to understand the algorithm in better way, then only you can use that for finding or selecting the learning algorithm. And if you have categorical data or numerical features, in that sense you have to focus on the algorithm, and based on your needs, training speed and prediction speed, non-linearity, etc. are to be considered for identifying or discussing the selection of machine learning. So in nutshell, what I am trying to say is, whenever you deal with some machine learning algorithm, you have to focus on the algorithm, the mathematical algorithm behind the approach. Then only you can go into deep sense, then only you can understand the algorithm in better way, then only you can explain your project, then only you can explain your project or explain your result. So my humble suggestion is, you have to focus on the algorithm and focus on your learning method based on all the topics that we discussed today, and I suppose that that makes sense. And also not only for the algorithm, also in the performance assessment, like computation metrics, accuracy, precision, etc. This mathematical rigor is required to understand that better way. Okay, so I suppose that I have done justice for the short span of time and discuss what are the mathematical requirements for understanding machine learning. I am having an idea that this task being conveyed, but one thing is sure that you might not able to understand, you might not able to go into very deep sense of each and every topic in short span of time. But what I am trying to tell is, you have to focus all on this topic and read materials which are available in your public medium or textbook or that sense. So first of all, learn the algorithm in a sufficient rigor. Then only go to the machine learning project. That will make you a machine learning expert also that will make you to understand the concept inside black box of machine learning. So my suggestion is open the black box of machine learning. For that you need to understand basic mathematics in the graduation level. Then learn the algorithm. Then after you apply the machine learning algorithm for the particular projects. So I have some more slides on neural networks and its method. I think we can wind up for the session for the time. So we can wind up now. So if you have any doubt, you can comment your doubt in the chat box, or if you need to have some more clarity on some portion, you can say that. Also, we can discuss offline. I think ICFOSS have designed or developed a community to discuss this kind of machine learning approaches, or a community to address this machine learning questions. So I'll be happy to comment, or I'll be happy to discuss this kind of aspect. So I'll also suggest you to read all the topic, all the concepts in some more deeper sense. Then you go forward with the machine learning textbooks. That will enlighten you to understand machine learning in some good way. Okay. So over to audience. If you have any doubt, you can ask.
We're now on YouTube.
Thank you, sir. That was a wonderful session. This is a Q&A time, and the participants can comment your doubts in the chat section so that we can ask. So one of our participants, Mithila is hearing. Mithila has asked why we use keras. Sir, can you please explain it about the usages and advantages of using keras?
Yeah. Kera is one of the important packages that is created for Python. So we are using keras because most of the machine learning approaches are hard-coded in the particular package. So we need not discuss or use the more thought on Python to make sense of your data. So once you go into this kind of package, TensorFlow or keras, either of these packages, you can do most of the machine learning algorithms. You can compute most of the machine learning projects. So that will be very easy for you. Otherwise, you need to sit and code in Python based on the mathematical knowledge and algorithmic knowledge. And the bad way is once you get into keras or TensorFlow, you plug in some data, you'll be getting some result. Okay. So the problem is, without understanding the method or concept in a deeper sense, you will get some result. So my gut feeling is most of the machine learning projects that is being done by students or in the academic area are not rigor in that sense. Students cannot explain that. Okay, students may not be able to explain that. So in that sense, what we need to focus is, we need to focus on the algorithm side first. For students, if any students are there in the session, I request all the students to go back to your graduate level mathematics and learn the concept in the graduate level mathematics steps. Then you try to read again and again the algorithms inside the machine learning approach. Then only you go to implement that. Okay. Also, most of the packages available for machine learning are open source. So you can open that particular source code and try to understand whether what is coming and going out from this particular variable. Okay. That is a basic requirement of machine learning. Otherwise, what happens? You will get some blah blah blah, and this you'll get some result, then what happens is finally for some presentation, for academic requirement you present that topic, then you get some, you are away from that. And sometimes if you are going with some serious machine learning project, like some industrial kind of projects, what happens is you can have a problem, you can have a kind of difficulty in managing this kind of data. Okay. Middle ranks. Okay. Difference between A and ML and DL. There is a big difference. In fact, I said it comes in different cup, different wrappers. Okay. There are different terminologies, different concepts in that. A contains ML and DL, etc. But to me, all this is machine learning in some kind of difference. In earlier time, it was known as soft computing. So it wrapped into machine learning after that, then deep learning, then AI. So conceptually, all these are statistical learning approaches or mathematical learning approaches on data. I think that answers your question. We are using tensor concept, so multi-dimensional data. That's a problem in sometimes if you're dealing with big data. That means, for example, multi-dimensional data. For an example, to put in perspective, I can say some data. For example, the COVID surveillance data or COVID patient data in Kerala. It's a matrix. Okay. Again, you will be having the same data on the time series for other states also, Tamil Nadu, Karnataka, etc. So, to analyze it together, okay, to analyze that in together, we need to have a multi-dimensional matrix. Okay, so that it is called tensor. Okay, so tensors are used in that sense. I think that answers you, right?
We're now on music.
Thank you, sir. I think we can move on to the next session, and that's the last session of our webinar. I think that all the participants had a wonderful time having this webinar. Thank you once again, sir. Now, we are moving on to the last session of the webinar. We have Dr. Rajiv Arar here. He is the head of e-governance and language technology team of ICFOSS. Sir, I welcome you to deliver the thanking note.
Thank you, Alina. Is it audible from my side?
Yes.
Yes, sir, yes.
Good afternoon, all. I think it's a great honor and privilege to purpose a lot of time on this occasion on behalf of ICFOSS. Let me first of all start by giving the glory to the Almighty of God for making this occasion a resolving success. First and foremost, I'll thank our chief guest and resource person Dr. Umesh P, Assistant Professor, College of Engineering, Talacheri, for having such a wonderful session. We are really enlightened with your knowledge and presence. We are thankful to our Honorable Secretary, Shri Muhammad Bhai Safullah IAS, for his motivation and support for this webinar, and all the subsidiaries of ICFOSS. Then we are grateful to our director, Dr. Shabirish sir, for his word of encouragement. His able guidance has always encouraged us. I thank him for his kindness, his interest, and continued support. I thank our Secretary and Registrar Sri Kumar sir for all his enthusiastic support to make this webinar as a great success. Also, I thank all my team who have worked hard to ensure this occasion became a memorable success. All the team members are in quarantine of these days, but they give all the support to us to for a great success of this event. And a special thanks to my fellow colleagues and all those in the organizing committee, our IT support team, administrative staff and researchers of ICFOSS family for their unlimited support and coordination. Thanks to our participants present here for their active participation with these warm words and a kind message. We move to end of today's webinar and expect all your presence in our future webinar sessions as well. And last but not the least, I thank you, my friends, for your cooperation in making this session a resounding success. Thank you all.
You are now unmuted.
That was wonderful. So let's catch up in the next webinar. The details of the next coming up webinar will be shared to you soon via social media platforms. So stay tuned and stay safe. Thank you all.